Okay, great. Thanks so much. Thanks for having me, everyone. I can sort of see the room, but so hopefully I'll see raised hands, but also feel free to just jump in if I don't. And so what I'm going to talk about today is sort of a mix of social NLP and computational social science, specifically focusing on what is the role that pre-trained language models have played in this space, where are there opportunities and where are there still kind of open challenges. So to give an overview, I'm going to start by giving a kind of quick introduction to what computational social science is and the types of questions that you find in that space. Then I'm going to go through 3 different kind of categories of methodology in this space, and I'll give kind of an example for each one. And then I'll kind of end like concluding with some of the open challenges here, which you'll sort of see throughout the talk. We might not have time to get through all of this, or maybe we'll get through really fast, but we'll see how it goes. So what is computational social science? This is a definition that I like. This is taken from a piece written by Hannah Wallach, who is currently a researcher at Microsoft. And she defined it as the study of social phenomena using digitized information and computational and statistical methods. So to give kind of a couple of examples, how does this differ from the types of problems that we typically look at in the NLP space? Well, on kind of the NLP side, one example of a question that someone might try to build a model for is, given a bill that's been proposed as legislation, predict how many people are going to vote for it. On the social science side, what kind of question of interest might be something more like, when and why do senators deviate from party ideologies? As another example, on the NLP side, we might be interested in predicting whether or not a candidate's going to be hired based on their resume. But on the NLP side, or on the social science side, we might be interested in broadly analyzing the impact of gender and race on the US hiring system as a whole. And just to kind of give you one last example, so on the NLP side, we might be interested in recommending related products to Amazon shoppers, but on the social science side, we might want to look at to what extent recommendations affect shopping patterns as compared to other factors. So just to kind of summarize a little bit, a lot of times what we're trying to do in NLP focuses on some sort of predictive task. And this isn't always the case. Obviously, there's other branches as well. But really on the social science side, often what we're trying to answer is more explanation types of questions. And so sometimes building a predictive model is part of that process, but it's usually not the end goal. And the goal is typically not trying to sort of maximize the model accuracy. We're trying to maximize what we can learn from the data. So this is an overview of common methodology in computational social science. This is drawn from a survey done by Justin Greimer and Brennan Stewart in 2013. So it's actually almost 10 years old at this point. But what I think is kind of interesting is how well these sort of categories still break down. I was looking through this and realized this is almost the same categorization as the way I organize this talk today. I'm just sort of grouping the time series and classification together. So that's something that I think is kind of interesting, how sort of little this broad framing has changed in the last 10 years. Though there is now these same authors have now written a book on this topic as of, I think it came out this year or last year. Yeah, so that might be a little bit different, but we'll have to see. So the first category of work that I'm going to talk about in this space focuses on supervised classification. And for this project, what I'm going to do is give you a little bit more in-depth of a look at one project that is in this space. And for some of the kind of later method categories, I'm going to move a little bit more quickly through examples. But this one, I want to kind of give you a broader sense of like what a project in this space looks like. So the paper that I'm going to talk about is a paper that just came out about a month ago, and this focused on analyzing tweets about the Black Lives Matter movement from summer of 2020. So to give a little bit of context, and this is something that I assume a lot of you are already familiar with, the term Black Lives Matter originated in social media posts made by two activists in 2013. But since then, it has become popularized as broadly referring to movements against police brutality and the extrajudicial killing of Black people. So in June 2020, there were widespread protests about the Black Lives Matter movement following the death of George Floyd. And throughout kind of these events in 2020, as well as earlier, and later, continuing through today, social media has been a really integral part of these events. It's used to share information, it's used to organize protests, it's used to recruit supporters. And so millions of tweets have been posted with hashtags, not just Black Lives Matter, but also things like Justice for George Floyd or I Can't Breathe. So there's a lot of text data out here. There's a lot of social media data. And given the role that social media has played in these events, understanding the dynamics of this movement on social media is really kind of a critical component to providing insight into the movement as a whole. So what can we kind of do from the NLP side? That means we have a whole lot of text data. We have more that anyone is going to go sit down and read through by hand. So this seems like a good use case for NLP. We want to do some kind of automated text analysis. But what do we actually want to do? What we have is a data set, and we don't really know what to do with it. So in order to kind of figure out what we think actually makes sense to look at in this data, we can start by reviewing literature on what motivates social movements and what kinds of questions social scientists are asking in this space. And in the last few decades, a lot of attention has been drawn to the role of emotions in events, going back to events like the civil rights movements in the 60s. I think there are even some earlier ones as well. And this sort of prevalent theory suggests that moral shocks that evoke outrage and anger is often what gets people involved in movements, but that more positive emotions, things like hope and optimism, are necessary to sustain involvement. And this idea of emotions is particularly relevant in the context of Black Lives Matter because of the ways that emotions have been used to stereotype and characterize Black people. So there is a prevalent stereotype refers to Black people as being angry, and this has led to things like tangible economic harms and been used to justify violence against Black people. And this is kind of true as well in the context of protests. So based on these motivations in this project, we develop a model to measure emotions that are expressed in tweets about Black Lives Matter. So how do we do this? First, we need to figure out what emotions we want to measure. So here we pull a taxonomy from social psychology research, and we focus on Ekman's taxonomy. There are others as well, but this taxonomy considers there to be 6 core categories of emotions and other emotions to be kind of subsets of these core categories. So for example, positivity includes both things like joy as well as hope and optimism, whereas anger also includes things like outrage. So next, as I kind of started this whole section, what we're talking about is supervised approaches. So if we're doing some kind of supervised learning, we need some annotated data. And here we draw data from a couple of sources. So the first is existing data sets that have been annotated for these emotion categories. There's a couple of a fair number that exist, but these two are both the two that I'm referencing here, called Go Emotions and Hurricane Emo, are both social media data sets. They're Reddit and Twitter, and they're both very large. So this is pretty good for being able to train a machine learning model for this task. However, we also need some data from our own domain. We need it at least for evaluation, if nothing else. And so we annotated as well tweets drawn from data about the domain that we actually want to study. And finally, so this is kind of enough for us to just train a supervised model, but we need to incorporate here as well some aspect of domain adaptation. And to give you kind of an example of why, so this is true in general, that we often care, particularly in a social context, of making sure that our models are measuring values that are relevant to the particular setting. It's sort of especially true when we're looking at something like protest movements, which often aim to raise new ideas, aim to subvert the status quo, and so are sort of intentionally breaking the norms that we might find in other cuts of data. So as one example, one of the kind of classic, really large lexicons of words annotated for different affective values, these are the NRC lexicons. Annotations on this lexicon associate the word police with trust. But if we take that into a new domain, into this domain of protest against police brutality, that's obviously not the same connotation that we're going to find here. Okay, so now we can train a classifier. So our baseline model for training a classifier to measure these emotions is just kind of a BERT-based classifier. I won't go into the details of the architecture. It's not very interesting. And so this is really sort of, in some ways, the use case that models like BERT have been shown to perform very well, is you take this model that's been pre-trained in another domain, but when you fine-tune it over data for specific tasks, then it improves very well. And we sort of kind of unsurprisingly find the same thing, that even just this baseline classifier performs a lot better than things like lexicon-based approaches, which is what's really commonly used by social scientists. The next thing that we do is start incorporating these concepts of domain adaptation. So the first method that we do for domain adaptation is pretty straightforward. We just do additional mass language model training over our target data set. So we take full data set of, I think about 34 million tweets, and we use that to do additional mass language model pre-training over the model that we eventually incorporate into the classifier, and then we fine-tune that model over the annotated emotion data. And this gives some improvement. It gives improvements for some emotions, but not for all emotions. And so we actually tried a number of different things here as well. And this is something that I think is kind of interesting. So we tried things like curriculum learning or like adversarial objectives to try to improve the domain adaptation. But the thing that we actually really found worked better than any of that was just using a couple of tweets from our own annotated data set, from the data set of Black Lives Matter tweets, and doing basically few-shot learning instead of zero-shot learning. So this numbers that I'm showing you, I think this was incorporating about 300 tweets from our own data set, along with the several thousands of tweets from Hurricane Emo and Go Emotions. And this is one of the areas where I think it's, you see sort of the difference in goals between what you might find in a kind of classic NLP project and what you might find in when what we're interested in is really just analyzing the data, because we don't care how fancy the model is. We just want to do what works, and what works is just annotating a couple of in-domain data set, in-domain tweets.
May I ask a question?
Yep.
Do we understand why some of these categories, the accuracy or the F1 is as a proxy measure of quality or performance? Why for some of these categories, these numbers are really low, like for sadness or fear?
Yeah, they're basically really sparse in the data. So fear and surprise are really rare in the set of tweets that we annotated. So that's true both in the tweets that we're adding in the training data, as well as in the tweets in the test data that we're annotating. So if your kind of, evaluation set only, if your test data set only has like 10 tweets that have fear in it and you miss one of them, then that like hugely impacts the F1 score. So I think that's why we see this. And this is also, it's kind of reflective of the domain in general, that expression, sort of like genuine expressions of fear and surprise, are really rare in social media. That's just not something, like if you're actually kind of experiencing fear, your first instinct is usually not to tweet about it. Yeah, so I think that's why it's really kind of the surprise and fear that the performances, and sadness as well. It's the same issue. They're all very rare in the data.
Thank you.
I got a question about the last slides. We get 3 data sets. Sorry. Yeah, so I'm wondering, since Go emotion and hurricane emo has different kind of taxonomy for emotion, so I'm wondering whether those three taxonomy can be converted to each other.
Yeah. Yeah. So we basically mapped them to each other. They are all of the, I think if I remember correctly, certainly Go emotions and is actually annotated for much finer grained categories. And then the authors have a suggested grouping of how to group them into broader categories. So they actually sort of like separately annotate things like, what's an example? So I think they have separate categories for, say, outrage and frustration, but both of those gets grouped to anger. And then Hurricane Emo, I think, did something similar. So we basically just defined a mapping to put all of them in like the Ekman taxonomy, because the Ekman taxonomy is very broad. So it's like not that hard to kind of map these finer grain emotions into these like broader categories. Okay, so now that we have this classifier for emotions, we can go ahead and use it to analyze how emotions occur in the data that we want to examine, which is tweets about Black Lives Matter protests. So this is an overview of the data that we collected. We ended up with about 44 million tweets, not including retweets. If you include retweets, it's a couple 100 million. Tweets posted from the end of May through the beginning of July. And we collected data around a number of hashtags and keywords. So we include hashtags that are both likely to be used by people who are supportive of the movement, as well as hashtags likely to be used by people opposed to the movement, as well as sort of general references to things like protests or police. And this figure here shows just the volume over time of our data set. So you can see that there's like really kind of a high peak in the beginning of June, and then it slowly drops off until the end of June. So before I get into the results, I just want to be upfront about some of the limitations in this work in what we can and can't measure. So first, we're looking at a sample from Twitter. And while we collect a lot of data, we didn't collect every single tweet that's relevant, I'm sure. So we don't really know how representative our data is of everything that might have been posted. The other thing is to keep in mind is that what we're really measuring here is emotions that are perceived in tweets. And this is a distinction that I think is really important, because there's sort of a lot of ethical questions around emotion classification in general. In that, should we really be trying to guess someone's emotional state? And that's not what we're doing here. We're not seeing what people might actually have experienced. We're seeing what someone was choosing to post and perpetuate on Twitter. The last thing that I'll kind of mention is all of the data is public. This is just scraped from Twitter API, but not users who kind of post on Twitter aren't necessarily explicitly consenting to have research done on what they post. So for that reason, in this work, we try to be conscious about preserving the anonymity of people who might be represented in this data set. So we can start by looking at words that are overrepresented in tweets labeled by our model for each emotion. And this shows both kind of sort of the limitations of this approach, as well as gives kind of a better sense of what we are and aren't capturing. So we see that we're not really just drawing distinctions between, say, anger at someone and anger on behalf of someone. We also see that what we're capturing here is very different than stance. Like, we get hashtags that are likely to be used both by kind of people who support the movement and who are opposed to it. But in general, we see a lot of kind of common hashtags represented in tweets labeled with our model for each emotion that are kind of very reflective of what we would expect. So in, for example, tweets that our models label with positivity, we find things like love and pride. In tweets labeled as containing sadness, we find things like RIP and sad. So one of the things that we can look at here is the way that these emotions measured by our model change over time in the data. So this figure specifically only shows the subset of tweets that contained pro-Black Lives Matter hashtags. So this doesn't include tweets that have things like All Lives Matter, unless it also had a pro-Black Lives Matter hashtag. And what we see here is there is an initial peak in sadness as well as an initial peak in anger. And this is sort of consistent with the idea that often what gets people involved in movements is these moral shocks. But we see sort of increasing growth in the rise of more positive emotions, and with a peak here around June 19th on Juneteenth. And so that is also kind of consistent with this idea that you need to have more positive emotions for there to be longevity to the movement. Some of the other things that we find is that these positivity is more prevalent in tweets that contain these pro-Black Lives Matter hashtags. So like across all of the data, anger is the most common emotion overall. But if we look at the subset of tweets that only contain pro-Black Lives Matter hashtags, then we actually find that positivity is more common in these tweets. And that's not true in other subsets of the data. So in subsets of the data of tweets that only contain anti-Black Lives Matter hashtags, or just contains like words that refer to police or protests generally. And finally, the last analysis that I'll show you on this project is we examine how these emotions relate to actual on-the-ground protests. So these are all geographic correlations. It's really hard to look at protest data temporally because, as you can see from this figure, it just participation in protest volume just peaks on every weekend and then goes down over time. So it's sort of not that temporally interesting. But what we can look at is geographically. So in sort of states and cities that had more or larger protests, what were the how was the emotions different with people who were in those, or at least affiliated with those states and cities, in terms of what they posted on Twitter. And what we find is that anger and disgust are both negatively correlated with on-the-ground protests, whereas positivity is positively correlated. Okay.
I have a question.
Yep.
Could it also be that I guess I can see that you're not calling it causation and more like a correlation. Like I guess can one person also explain this spikes of positivity by arguing that people just do weekend things on weekends and people are more positive on weekends, and there might be other correlates that explain this spikes.
Yeah, sorry, I should have introduced this a little bit more clearly. So what this is showing, like where we're seeing the spikes on weekends, is the number of protests that occurred. This is, I think, like aggregated across the US. So basically there are more protests on weekends. So that it makes complete sense. During the week, people are at work, and on the weekends, that's when they have time. When we're seeing these positive correlations, so like for that reason, we don't look temporally at the data, because it's just like sort of too hard to control for, we don't have a long enough time period to be able to control for this like effect of weekends. So instead, what we look at is geographic correlations. So what we see is that in cities and states where there were more protests, there was also higher proportions of positivity posted on Twitter. So again, like we're still not capturing any kind of causal relationship here, because when we're looking just geographically, what that means is we're finding both. We could be finding what people are posting like after or during a protest as well as before. So it's not as if like, okay, if there's a lot of hopeful posts on Twitter, that means people go to more protests. It could also be the opposite. That's like when there are more protests, that leads to feelings of camaraderie, and that leads to feelings of like hope and excitement and enthusiasm. And so that's like, we can't conclude anything about like which direction the correlation is in, because we're just looking geographically.
Got it. Makes sense. Thank you.
Okay, so just to kind of summarize, so some of the things that we find in this work is that although there are these stereotypical portrayals of protesters that focus on anger and outrage, what our analysis actually finds is we consistently see the prominence of these positive emotions, things like hope and optimism, that they're also very prevalent on Twitter and that they're correlated with on-the-ground protests. And so this kind of work in general goes towards both understanding what are components of social movements and what is this offline-online relationship in a setting like this, as well as offering evidence to refute some of these stereotypes. So to take a little bit more broadly and go back to this sort of overall higher level thinking about what are the methods that we actually use here from the NLP side, basically the benefit that we're getting out of having a pre-trained model is that it's a better classifier than if we used something else. The fact that this model has been built with this with this pre-training objective, that also allows us to do some sort of very easy domain adaptation because we can just do additional pre-training on the domain that we're interested in. But one of the kind of big downsides here is that we're really just doing supervised classification. And so what that means is we still need in-domain annotations to improve performance and evaluate. So this model isn't just like completely generalizable as is. We still needed to go and annotate data in order to improve the model as well as evaluate it. And so this is kind of a downside. In some ways, it's not that hard to annotate a few hundred data points, but this project also took us a long time and multiple rounds of doing kind of initial data annotations and then improving the annotation scheme. And so this is kind of a downside of this type of approach. So I'm going to talk about some other alternatives. So what you can do if you don't want to do so much kind of a straight supervised classification model. And I'll give, in these sections, I'm going to kind of go a little bit higher level on some of the examples and not kind of get as in-depth in some of the results, but I'll just kind of give you a couple examples. So one of the things that you can do if you don't want to do something supervised is to do something unsupervised. And basically, this typically in practice ends up being some form of clustering. And in kind of the social science side, one of the most popular ways of looking at a new data set, so given some new data, you don't know anything about it, and you just want to be able to understand what are some trends in the data, is to do topic modeling. I'm guessing most of you have seen topic modeling before, but perhaps not everyone. So just to give like really kind of high level hand wavy overview, basically what your kind of classic topic model assumes is that every document in your corpus contains some mixture of topics, and that each topic uses some mixture of vocabulary words, and that your goal is to be able to recover these topic and vocabulary distributions. So given a document, you want to be able to recover what is the proportion of each topic used in that document, but what your topics are actually just distributions over your vocabulary. You can't really define, since you're doing this in kind of a totally unsupervised way, you can't really define exactly what you mean by a topic. So the way you kind of get at a topic is by inferring like which words are commonly used across articles. So one of the still very common ways of doing this, and if you go to kind of social science venues, you'll still see this a lot, is to do to use a method that's called latent Dirichlet allocation, or LDA. And what this method does, it's a very kind of classic example of a generative model. It effectively assumes that you wrote this corpus of documents by selecting words out of bags, and you're trying to infer what the bags are, like what the sort of number of words in each bag was. And so it assumes this kind of generative process of creating a corpus, and then your goal is to infer these parameters. And there's a number of approximation methods for doing this. And basically you assume that your generative process was done in such a way so that it's computationally tractable for you to compute. So it's kind of limiting because you're using a lot of supervising assumptions, but in practice, it's shown to be a pretty effective way of doing some kind of unsupervised clustering. So as of about 5 years ago, as with sort of everything else in the text world, there started to be kind of more neural versions of the classic topic model. So this is one that was called prod LDA. I think this was the sort of, as far as I know, the first kind of very generalized neural version of a topic model. And they basically use the AEVB inference algorithm to this sort of slightly generalized and modified LTA. So this is sort of a neural approach. And then as of about last year, we now are starting to see the incorporation of features from contextualized, so pre-trained language models. So the one that I'm going to show you a couple of examples from is called contextualized topic models. And this is basically an extension of the prod LDA model, but in part of one of the inputs into the model is features that are taken from a pre-trained language model. So I think they usually, well, you can kind of specify which model you use, but basically in addition to the sort of classic bag of words features that are going in that you use in LDA, you just append on the outputs when you run run the first couple of sentences in your document through a language model like BERT. Okay, so what does this look like in practice? I'm going to give you an example from a different kind of work. And so to do that, I need to introduce the data and give you a little bit of context before I just kind of show you what the output of the model looks like. So as most of you probably know, on February 24th, Russia began an open military invasion of Ukraine. And this conflict, in addition to being a physical war, has often manifested in ongoing information warfare, as Russian, Ukrainian, and allied forces attempts to shape the online narratives of the war. So when we think about this kind of space, what can we sort of as NLP people do about this? How do we investigate this information warfare that's happening in this war? And one of the first things that we can start by doing is just collecting data. So this is what we did. We collected data going back as far as January 2021, so over a year ago, and still continuing to collect data, but what I'm going to show you ends with the data as of May 31st, 2022. And so what that means is, since we've collected data in this way, it includes a couple of time periods, includes data that both was posted before the war as well as after the war. We also, I'm just using this term data very vaguely, so where are we actually getting it from? We collected data from two different platforms. So one is Twitter, and the other one is VK, which is effectively Russian Facebook. And we specifically on these two platforms, we collect posts that were made by different news outlets. And we collect posts that were made by news outlets that are sort of known and broadly openly state affiliated. So by which I mean affiliated with the Russian government, as well as outlets that are more independent. And even here, the independent is a little bit of a deceptive term. A lot of these independent outlets may still be influenced by the Russian government in some way, but they're not sort of openly affiliated. So if we take a quick look at some of the word statistics in this data that we've collected, this figure shows the proportion of media posts that mention, that basically reference the war using a list of keywords. So this includes using terms like war or military operation. And what we see is beginning after the invasion started at the end of February, we see that these independent outlets use these terms more frequently. So they kind of use it more frequently overall, but especially after the invasion started. And this is sort of consistent with a lot of more anecdotal evidence that people have said about the war, so that things like that Russian news outlets aren't really reporting about the war, that people in Russia don't know that the war is happening. And this is something that we can see reflected looking at these word statistics of which words are more frequent in posts made by state-affiliated outlets as compared to independent outlets. But this is just using keyword lists, and we have to come up with keyword lists manually, and we might not have gotten all the keywords. So we can also try to do something that's like a little bit more robust by using these contextualized topic models. So this figure here is, this is sort of selected topics that we get when we run contextualized topic models over this data set of social media posts made by news outlets. It's kind of hard to interpret, but if we focus on two of these topics that are sort of contain the most war or military related terms, and if we look at just these topics, it looks like these topics are actually tend to be more represented in state affiliate outlets than independent outlets. So this is the opposite of what we saw when we looked at these word statistics. However, if we look kind of more closely at these topics, so what we can see is that there's evidence that we're not really kind of capturing these terms broadly. So particularly down here in this topic 5, DNR and LNR, the abbreviations that are specifically used by the Russian government to describe contestant regions. And so we can kind of infer that these topics might really be actually sort of explicitly picking up the way that the state affiliated outlets talk about the invasion, more so than just like references to war in general. So this is like showing kind of both the advantages and disadvantages of using these sort of unsupervised clustering methods, as opposed to what we did in the previous project where we just sat down and annotated data. Here we didn't have to do any annotated data. We were able to do this much more quickly. But on the other hand, it's a lot harder to tell exactly what we're measuring, and we have a lot less control. And so in these sort of social applications, that's often kind of a problem because we really care about making sure that we're measuring the right thing. That's kind of the whole goal. Okay. So that was just kind of a quick example of what these sort of unsupervised clustering approaches look like. And yes, we can incorporate some of these pre-trained model features and that they might improve topic coherence, but we still don't necessarily have a lot of control over what the model is learning. So the last example, the last kind of category that I'm going to talk about is looking sort of at, for lack of a better word, embedding projections and sort of ideology mapping. And I'll give you kind of 2 examples of work in this space. So the kind of origins of what I mean by embedding projections, a lot of it goes back to this paper that I'm guessing you've probably seen before, and it's titled "Man is to Computer Programmer as Woman is to Homemaker, Debiasing Word Embeddings." So as a quick refresher, basically what this paper showed is that if you look at kind of static word embeddings, there is signs of bias, and particularly look at in this work, they look at gender bias around occupations. And so they show that the embeddings for certain occupation words like librarian or homemaker or nanny are much closer to words related to women or like the pronoun she's, whereas in the embedding space, whereas words like philosopher or financer are more related to words relating to men or male pronouns. So when this paper came out, there were kind of 2 separate papers been like widely cited and in 2 kind of very different ways. So on the one side, the reaction in the NLP community and in the machine learning community is how do we remove these biases from these models? That this is a problem and we don't want to deploy biased models. And so it kicked off this whole line of work on sort of model debiasing in general, and particularly in model debiasing of word embeddings. And now we're seeing kind of extensions to that in debiasing of pre-trained language models. But this also kind of set off a separate branch of work on the social science side, which was, this is potentially a really great tool to be able to measure biases in an unseen corpora. That this like kind of concept of bias is something that's really hard to pin down, and we don't really know how to measure it. And there's like now potentially these models just learn it, and we can use that to measure it. And so that's actually like kind of a cool thing. So this example here, this figure is drawn from one paper that looked at gender and ethnic stereotypes in over a 100-year period using basically word embeddings. Okay, but this is all kind of using static word embeddings. So there's a question here now of how do we use these newer models? How do we use a model that has contextual, how do we use, say, contextualized embeddings or features out of a pre-trained language model? So I'm going to give you one example of work in this space, and again, kind of highlight what are some of the advantages and disadvantages of this method. So the example that I'm giving you focuses on examining how people are described in terms of power, agency, and sentiment in narrative text. And why do we want to know how people are described in these terms? There's a number of reasons, but just to kind of give you one like short example, this lets us be able to address look at questions like, do news articles portray women as less powerful than men? If we can examine how these, say, like women and men are portrayed in terms of power in these articles. And so when we try to draw this sort of analogy to the type of work that's been done with static word embeddings, this example of, say, like man is to computer programmer as woman is to homemaker, these examples are drawn from existing lists of occupational stereotypes, like the stereotype that women are homemakers and the stereotype that men are computer programmers. So fortunately, in this space, we do as well have kind of existing lexicons annotated for power, agency, and sentiment that we can draw for in kind of a similar way. So just to give some high-level methodology, what we can do is for words in these annotated lexicons, in these like power agents and sentiment lexicons, we can run sentences that contain these words through our model and get out some kind of feature representation. And we can do the same thing for the entities that we actually want to examine. So if we want to look at how Hillary Clinton and Donald Trump are described in news corpora, we can pull sentences that reference these people out of these corpora and run them through to get some feature representations. Then there's two different ways that we can kind of reconcile these. So one is we can basically do a supervised classification. So we can just train a model to predict power, agency, and sentiment from the embedding lexicons, the embedding representations of the lexicons, and use that to infer the same over the embedding representations of the people who we are interested in examining how they're described. The other thing that we can do is something that's a little bit more kind of embedding, like a little bit more directly relating to this idea that there's this embedding space and that we can identify things like a power subspace or a gender subspace in embeddings. And we basically can identify these subspaces using our lexicons and project our entities into them. And so this kind of is like a little bit more similar to the kind of work that's done with static word embeddings. And so when we do this over a data set, this does kind of work. It lets us draw some kinds of results. So for example, when we run this over a large data set of newspaper articles, we can find things like women tennis players tend to be portrayed with more positive sentiment, but we find that male tennis players tend to be portrayed with more power. But one of the problems here is that when we try to evaluate these methods in a data set that sort of explicitly inverts traditional roles. So in this example, we were looking at a data set of the Me Too movement, and we find that the method doesn't work as well. And one of the reasons that that's the case is because when we're using a model that's been pre-trained on other data, that captures a strong signal, not just about the surrounding context, but also about the token itself. So when we take a sentence like Hillary Clinton lost the 2016 election, and we try to run that through, say, BERT, we're not just capturing the context of that sentence, we're also capturing however Hillary Clinton was depicted in the pre-training data, not just in this sentence. So now, like, we're having a hard, like, it's hard for it to be able to disentangle what we're measuring from our training corpora from the actual corpus that we want to analyze. So there's some ways of getting around this, like you can do things like masking out the name of the entity and focusing only on the context, and hopefully that kind of distinguishes between these things, but that really kind of degrades the embedding quality in practice, and we find it doesn't work as well in other evaluation metrics. So there's still some kind of use cases for this sort of approach. If we're not really looking at one particular corpus, then we can, and we're just sort of looking generally maybe at even like how these people are described within a model representations, then we can still kind of do something like this. It's also useful for being able to looking at comparative questions where we're looking at the same tokens in different contexts. So how is Hillary Clinton described in one corpus as compared to a different corpus, or how did that description change over time? But there are sort of then limitations about where we can use a method like this, because we can't distinguish between our pre-training corpora and our analysis corpora. Okay, so I have one last example, and then I'll kind of conclude. And this example is this approach is also in this kind of subcategory of what I would consider this embedding representation space. And this is also a kind of really newly released paper, came out just a few months ago. And I think that the method that they use here is really cool, which is why I wanted to share it. And what this goal is looking at, what this paper looks at in general, is the way that immigration is described in US political speeches. So they do a whole bunch of analysis here. I'm only going to go over one kind of really small subset of what the whole paper looks at. And the subset that I'm going to focus on is what they aim to do is measure implicit dehumanizing metaphors in these US political speeches. So what do I mean by kind of dehumanizing language? So as an example, as two examples, they find in looking at these speeches, they find metaphorical language that refers to kind of conflating immigrants with animals and immigrants with, say, cargo. So this includes language like sentences like using words like herding, as well as things like dumping. And they're interested in trying to measure instances of how commonly these types of dehumanizing language occur in this corpora. And so the kind of general idea here is we have two corpora. You have the analysis corpora that you actually want to analyze, which is these US political speeches. And as well, you have the training data that went into training a pre-trained model. I think they use BERT here. They might actually use Roberta, but it doesn't really matter. So you have the kind of data that went into training this model. And the key kind of idea behind this approach is that if you find the terms, so if you find in this particular context, since we're looking at immigration, so if you find terms like displaced persons or immigrants or Germans are used in similar sentences in the analysis corpora as words related to, say, as words related to things like animals or cargo, so things that are used as explicitly dehumanizing metaphors, they look at, I think, 6 or 7 of them. And if these words are used in similar sentences in the pre-training corpora, then this implies that there's some kind of dehumanizing metaphor going on in the analysis corpora. So this, in the kind of previous example, one of the sort of issues is that it's difficult to disentangle the analysis corpora and the pre-training corpora, but here that's sort of the explicit goal, is to be able to identify in the analysis corpora when are things reflective of what's happening in the pre-training corpora. So the method here is pretty straightforward. So you start by identifying sentences in the analysis corpora that mention the groups of people that we are interested in studying. So you might have a sentence like the tendency of displaced persons to flock together. Mask out the actual term that's referring to the people that we're interested in understanding how they were described. And then run that sentence through a model like BERT, and use that model to measure how which words could be replaced in that mask, like which would be scored high by the model. And if you find that the model in this masked out sentence assigns high scores to these metaphor dehumanizing words, so references to things like birds, then you can infer that there's a dehumanizing metaphor here. So all you're really doing is just masking out the entities and then looking at the output probabilities from the model. And they do this, right? And then when they do this, run this method over these modern political speeches, what they find is that in modern speeches, so starting around 2001, there's a lot more dehumanizing language used in speeches by Republicans about immigration than in speeches by Democrats. But sort of interestingly, that wasn't the case about a century ago.
Question.
Yep.
How should I interpret these plots here? Is like tendency toward the right side of the plots means more dehumanization tendency?
Yeah, so I think that they are looking at is the like relative frequency of dehumanizing language in Republican speeches as compared to Democratic speeches. So further to the right is more common in Republican speeches, and further to the left is more common in Democratic speeches. Right, so that's in like the 1880 to 1912 plot, there's not a big difference, but in the 2001, 2020, then there's a shift towards the Republican side.
Got it. I guess I personally would also be interested in seeing how this these tendencies would look like for different immigrant categories too, I suppose.
Yeah, I think they did. I think they did that, and I don't remember. So there were some differences that they found for different groups of people that were pretty interesting. I don't remember if those differences were specifically on dehumanizing language, because they looked at kind of other things too. I'm just showing you like one tiny part. But yeah, it's in the paper.
Got it. This is very interesting.
Okay, so I'll just end. I'll just conclude by doing kind of a summary of what we talked about. So looked at a couple of different ways that people are using or are developing ways to use pre-trained language models in these social applications. So one is just straight for you can use a pre-trained language model as a better classifier. And the example of that I showed you was looking at emotions in tweets about Black Lives Matter. Another is you can try to use features from these models in unsupervised clustering ways. So as an example, you can incorporate them into topic models. An example that I gave you for this was looking at looking at discussions of war in state-affiliated and independent Russian media outlets. And then a third way is to try to do to sort of treat these representations obtained by these pre-trained language models as reflective of some sort of projection, embedding space, or ideology mapping. And I gave you kind of two examples of this. So one is just directly looking at entity embeddings in order to analyze narrative text along dimensions of power, agency, and sentiment. And then the other is this metaphor detection approach. And this was looking at dehumanization in dehumanization about immigrants in political speeches. So there's kind of a couple of common open challenges in this space, particularly in how can we use pre-trained language models in social applications. So one of them is that sort of like what works pretty well is doing some data annotation, but that's annotating is slow and difficult. It also can introduce, this is something I didn't touch on as much in this particular work, but it also can introduce annotator bias. And so that, again, can kind of conflate what exactly you're trying to measure. The other is this need to disentangle pre-training data from analysis data, that this is something that we don't really have a good sense of what we might be introducing into our data set when we're using a model that was pre-trained on other data. Another kind of challenge, and this is sort of true very broadly, not just in this space, but these methods are often difficult to interpret, and in a social science context, and so where we're interested primarily in explanation, we really care about interpretability. So that's kind of a major downside here. And the other that I also didn't get to as much yet is that the bottom line is these models are not that easy to use. They require a lot of compute, and they also require some knowledge of how to use them. And this is something that makes them kind of less accessible to other researchers. So I have this kind of belief that if you want your code to be used by social scientists, you need to make it into an R package. That's like where a lot of the tools have gotten kind of picked up, and that's not something that's really the case with sort of modern NLP. It's not really, no one's really ported it to R yet, so I think there is work on doing that. And so given kind of some of these limitations, just some kind of like higher level thoughts on this space is that you get really far in these types of social analyses with things like word statistics. I showed you a few examples of that, as well as lexicon approaches. And these methods are kind of really, from an NLP perspective, not as interesting perhaps, but also they're really easy to use. They're very, the interpretation is very clear. And they often give you a pretty kind of interesting look in the data. So I actually think it's kind of interesting that the sort of bar that is set by these sort of lexical approaches is actually quite high.